so I'm going to go through some examples on IXL for the dilations of functions section, just because I know it can be a little confusing and a little bit tricky, and it takes a little while to get used to the rules. So here we have f of x is equal to 3x plus 1, and then it's becoming x plus 1. So what we want to notice, first of all, is that the only thing that's being affected in this case is our x, right? The x is being multiplied by 3, and then it's being multiplied by 1 technically. This plus 1 doesn't change. So when there's no change in the entire function and only one part of the function, that means this is some kind of a horizontal dilation. So the next thing that we need to think about is we're starting from at 3, and then we're changing to 1. So how do we get from 3 to 1? Well, you multiply it by 1/3. 1/3 is a smaller number. It's between 0 and 1. So when we're thinking about horizontal dilations, you want to kind of think opposite. So 1/3 is a smaller number, so really this is actually a horizontal stretch. So the answer for this question will be horizontal stretch. Here is our next problem, -4 absolute value of x plus 9, and that becomes -2 absolute value of x plus 9. So again, that number at the end didn't change, so this makes this some kind of a horizontal dilation because it only affected the x. And now we're going from 4 to 2. How do we get there? You take 4, you multiply it by a half. 1/2 is a smaller number. So if we're talking about a horizontal dilation, a smaller number means a stretch, which is kind of ironic. Smaller numbers you would think shrink, but not for horizontal dilations. Horizontal dilation, if it's a smaller number that we're multiplying, then it's going to be a stretch. So the answer here will be a horizontal stretch. All right. Again, we have similar for x squared minus 7 becomes x squared minus 7. Same idea. The 7s don't change, so we know it's going to be horizontal. We're going from 4 to 1. So we're multiplying it by 1/4 to get there. This is going to be a horizontal stretch. All right, this next one, we're going from x minus 1 and converting it to 3x minus 3. This is an example where we have a change in the whole function. The whole function is being multiplied by 3. This is being multiplied by 3. This one that we have there and this one there is also being multiplied by 3. So this means we have a vertical dilation, and when it comes to vertical dilations, a big number, a number that's bigger than 1, is going to actually be a stretch. So we have vertical stretch for this problem. And we'll do another one of these examples. We're going from absolute value of x minus 1 to 6 times absolute value of x minus 6. So both of these terms are changing, so we know that it's going to be a vertical dilation. And we're going from 1 to 6, so we're multiplying it by 6. A big number is going to mean a vertical stretch. Let's do one more just for fun. So -8x squared plus 4 is going to become -2x squared plus 4. So we're not changing this plus 4 at all. So we know it's going to be a horizontal dilation, and we're going from -8 to -2. To get there, we would have to multiply by 1/4. So a horizontal stretch is going to be the correct answer because 1/4 is a smaller number, and horizontal dilations, smaller number means stretch. Okay, so I'm going to stop here. Let me know if you have any questions. I know that dilations can be a little bit tricky, but once you get the hang of the rules, it will get a lot easier, I promise.